All right, let's jump right in. Today, we're going to talk about a really core piece of the Effect server ecosystem, the HTTP router. If you're looking to build web servers that are fast, totally type-safe, and can scale up with Effect, well, this is pretty much where it all starts. Okay, so here's what we've got on deck. We'll kick things off with what the HTTP router even is. Then we'll get our hands dirty and define a route. After that, we'll see how to safely grab data from a request. Next up, we'll talk about putting bigger apps together using middleware and mounts. And to wrap it all up, we'll dive into Effect's awesome type-safe error handling to make our app super robust. First up, what is the HTTP router? We'll look at how it blends a functional style with a more traditional approach to handling web traffic. So first thing you should know is that Effect actually gives you two choices for routing. On one hand, you've got the HTTP layer router, which, as the name suggests, is all in on Effect's dependency injection system, layers. But we're going to focus on the other one today, the HTTP router. The cool thing about this one is that it has this really direct Fluent API. If you've ever used something like Express.js, it's going to feel right at home, but it's got this awesome functional spin on everything. So when we say functional, what are we really talking about? Well, the key word here is immutability. Think of it like this. In a lot of web frameworks, you have this one big router object, and you keep adding routes to it, changing it in place. With HTTP router, that's not how it works. Every time you add a route, say a new GET endpoint, you don't change the original router. Nope. Instead, you get a brand new router back with your new route included. This might sound small, but it's a huge deal. It wipes out an entire category of bugs related to side effects and timing issues. And your testing life becomes way, way easier because your router isn't some stateful thing. It's just a value. All right, let's get practical and define our first route, going from a simple path to a handler. It's really just 3 simple steps. First, you start with a router and pick your HTTP method, so you'd chain on something like .get or .post. Second, you give it the URL path, like /users. And third, you write the handler. That's the piece of code, the effect, that's going to run when a request actually matches that route. The whole thing is designed to be super clear and easy to read. Okay, so that handler we mentioned, it's not just some random function. It's something called an HTTP app. And here's the kicker. An HTTP app is basically just a fancy name for an effect. And that is a game changer. It means that all of your request logic, from start to finish, gets to tap into the full power of Effect. We're talking completely type-safe errors, easy dependency injection, and that amazing structured concurrency that guarantees you'll never have orphaned processes. It's all just there for you. And check this out. What does your handler effect actually have to return? It just needs to be something respondable. This is such a clever idea. It means you can forget about manually building HTTP responses. Seriously, just return a plain old JavaScript object, and Effect is smart enough to turn it into JSON, set the right content type header, and everything. Or return a string, and it becomes text/plain. It just handles it for you. It's brilliant. Okay. Static routes are fine, but things get interesting when they're dynamic. Let's talk about accessing request data safely. So let's say you've got a route pattern like /products/ID, and a request comes in for, say, get/products/123. Obviously, that 123 is the important part. It's the ID we need to fetch the right product. The big question is, how does our handler code get that 123 from the URL? And how can we be sure we're doing it safely without just manually splitting strings and hoping for the best? The answer is something called the RouteContext. And this is where the magic happens. When the router finds a match for a request, it automatically pulls out all the dynamic bits from the URL. So for /products/123, it knows the ID is 123. It packages all that information up into this RouteContext object, and then it injects that context right into your handler's environment, making it available to your effect. So yeah, the RouteContext is your official, type-safe way to get at that route data. There's a super fast matching engine under the hood doing all the hard work of parsing the URL, and this RouteContext is just a clean service that makes the parameters available to your code. No globals, no mess. As your app gets bigger, you need to stay organized. That's where composing with middleware and mounts comes in. First, let's talk middleware. This is a classic idea, right? You use the .use method to apply some logic to a whole bunch of routes at once. Stuff like logging every incoming request, checking for an auth token, or gathering metrics. It's perfect for that kind of cross-cutting concern. Now, for bigger picture organization, you've got 2 main tools, Mount and mountApp.
They sound similar, but they're for different jobs. Use mount when you have multiple HTTP routers that you want to stick together. So maybe you have a whole router for user-related stuff and another for products. You can mount both of them under, say, /API. But mountApp is a bit different. It's for when you have a generic HTTP app, maybe it's from another library or just a standalone piece of logic, and you want to plug that whole thing in under a certain path. It gives you a lot of control. Okay, now for the really important stuff. What happens when things break? Let's talk about how to build a bulletproof app with robust and type-safe error handling.
The secret weapon for error handling in the HTTP router is a method called .transform. This thing is like a master key. It lets you take any effect function and wrap it around every single handler in your entire router. It's the fundamental building block for all the more specific error handling tools. And what's so cool here is that this maps directly to Effect's whole philosophy on errors. Think of .catchall as your general safety net. It catches any unexpected error and lets you return a generic "oops, something went wrong" page. Then you have .catchTag, which is more like a sniper rifle. It lets you target a specific kind of error, like a user not found error, and handle just that one case, maybe by returning a 404. And finally, there's .catchall cause. That's your black box recorder. It captures everything about a failure, even the unexpected crashes, which is perfect for deep dive logging and debug.
So what's the bottom line here? The HTTP router is way more than just a tool for matching URLs. It's built on these core ideas. It's functional and composable, it's immutable so you don't get nasty side effects, and most importantly, it's completely type-safe from the moment a request comes in to the moment a response goes out. It really brings the power of effect to the edge of your application. So I want to leave you with this question to chew on. What happens when your server's routes stop being this big, global, mutable thing that everyone has to be careful with? What if instead your router is just a value, an immutable data structure that you can build up, pass to functions, and transform? How does that fundamentally change how you approach designing and testing your APIs? Think about it. Thanks for tuning in.